Welcome back to our channel. Today we are going to discuss about geometric interpretation of derivatives. Geometric interpretation of derivatives. Consider the Cartesian plane with x and y coordinates. On this Cartesian plane, consider a function y is equal to f of x. Now, what do you mean by a Cartesian plane? A Cartesian plane is defined as a two-dimensional coordinate plane which is formed by the intersection of x-axis and y-axis. The x-axis and y-axis intersect each other at the point called origin. Cartesian plane is defined as a two-dimensional coordinate plane which is formed by the intersection of x-axis and y-axis. These two axes intersect each other at the point called origin. This is a Cartesian plane. So let's take a Cartesian plane with x and y coordinate. On this Cartesian plane, we consider a function y is equal to f of x. This is the curve of the function y is equal to f of x. Let's take any two points on the x-axis. The first point is A and the second point is A plus h. The distance between these two points is h. Connect this particular A with this function curve. If you draw a line on the y-axis and this forms f of a, in the same way connect A plus h with the function curve y is equal to f of x. By a straight line on the y-axis we got f of a plus h. Is it clear? Here we consider a Cartesian plane with x and y coordinate. On this Cartesian plane, we consider a function y is equal to f of x. This is the curve of the function y is equal to f of x. Here, now take any two points on the x-axis. The first point is A and the second point is A plus h. Connect this particular A with this function curve. If we draw a line on the y-axis, this forms f of a. In the same way, connect A plus h with the function curve y is equal to f of x by a straight line on the y-axis so that f of A plus h forms. Clear? Now join the points P and Q. It forms a straight line. Join the points P and Q, it forms a straight line. This is the curve of the function y is equal to f of x. This is the point A and B. Now take any two points on the Cartesian x-axis, that is A and A plus h. This is f of a and this is a plus h, f of a plus h. This point we call it as P. This is Q. For the point P, on the x-axis we have A and y-axis we have f of a. So the coordinate of P are A, f of a. In the same way, for the point Q, on the x-axis we have a plus h and on the y-axis we have f of a plus h. So the coordinate of Q are a plus h, f of a plus h. Is it clear? Now extend this line over here so that this point is called R. So that we got a right angled triangle at R. So the triangle is triangle PRQ. This is the diagram. Using this diagram, we can represent the geometric interpretation of the derivative. I'll explain it in detail. This is the curve of the function y is equal to f of x. This is the curve of the function y is equal to f of x. Let's take any two points on the x-axis, that is A and A plus h. These are the 2 points on the x-axis. The distance between A and A plus h is h. Connect this particular A with this function curve. Connect this particular A with this function curve. If we draw a line on the y-axis and forms f of a. Similarly, connect a plus h with the function curve. Connect a plus h with the function curve y is equal to f of x by a straight line on the y-axis so that f of a plus h forms. Here, this point is P and this point is Q. Join P and Q by a straight line. The coordinate of P are on the x-axis we have A and on the y-axis we have f of a. So coordinate of P are A f of a. So similarly, what about the point Q? On the x-axis we have a plus h, on the y-axis we have f of a plus h. The coordinate of Q are a plus h, f of a plus h. Now extend this line over here. This point we call it as R. Now we get a right angled triangle PRQ right angled at R. This is our diagram. Using this diagram, we can represent the geometric interpretation of the derivative. Using this diagram, we can represent the geometric interpretation of the derivatives. By referring this diagram, we have to derive the formula. Here, y equal to f of x be the function. This is the curve of the function y is equal to f of x. Here we have to join 2 points P and Q. We get a straight line. Now, slope of the line equals m is equal to tan theta. That equals y2 minus y1 by x2 minus x1. We know that both of them are the formula for finding slope. M is equal to tan theta and m is equal to y2 minus y1 by x2 minus x1. Both of them are formulas for finding tan theta. Now here, first we find y2 minus y1 by x2 minus x1. Then we find tan theta. Then prove that these two answers are same. So we equate tan theta, the answers of these two. Is it clear? Here, let P A f of a and Q a plus h f of a plus h be the 2 points. These are the 2 points. So we know that slope of the line m equals tan theta, that is equal to y2 minus y1 by x2 minus x1. First, we can find out the slope of the chord PQ. So what about P? P is a f of a. Q is a plus h f of a plus h. So this is x1, a is x1 and this is y1. This is x2, y2. So that find the slope of the chord PQ equals f of a plus h. That means y2 minus y1 by x2 minus x1. What is y2 here? F of a plus h minus f of a by a plus h minus a. x2 minus x1, a plus h minus a. The minus a and plus a get cancelled. Here we got f of a plus h minus f of a by h is equal to tan theta. We got this. Value of this is find y2 minus y1 by x2 minus x1. We got f of a plus h minus f of a by h. Is it clear? For finding the slope, we have two formulas. M is equal to tan theta as well as M is equal to y2 minus y1 by x2 minus x1. Here we use M is equal to y2 minus y1 by x2 minus x1 and we got the answer f of a plus h minus f of a h. And this is also equivalent to tan theta that we write here. Why? Both of them are the formulas for finding slope. Now write f of a plus h minus f of a by h is equal to tan theta, that we m is equal to y2 minus y1 by x2 minus x1. What is y2 minus y1 by x2 minus x1? That is f of a plus h minus f of a by h. Now find tan theta. Now consider a triangle PRQ right angled at R. PR is the base or adjacent side QR is the perpendicular or opposite side and PQ is the hypotenuse. What is the formula for finding tan theta? Tan theta equals opposite side by adjacent side or perpendicular by base. What is the opposite side here? QR by adjacent side is PR. Tan theta equals QR by PR. By referring this diagram, find, not this diagram, from previous diagram, by referring the previous diagram, find QR and PR. This is the previous diagram. Our x-axis and y-axis, both of them are meet at the point O. This is the curve of the function y equals f of x. Consider 2 points A and A plus h on the x-axis. Distance between these 2 points is h. This is the point P, this is the point Q. Coordinate of P are A, f of A, and coordinate of Q are A plus h, f of A plus h. Now join P and Q, we got a straight line. So we got tan theta equals QR by PR. By referring the diagram, find the value of QR and PR. What is QR here? This is QR. How to find QR? QR equals BQ. This BQ minus BR. This BQ minus BR gives QR. This whole BQ minus this distance gives QR. QR equals BQ minus BR. This whole distance is BQ minus BR gives QR. In the same way, what about PR? This is PR here. So, OB. This OB minus OA gives AB. AB is same as PR. OB minus OA gives AB. AB. Instead of AB, we write PR. So PR equals OB minus A. What about OB? Distance between O and A plus H. That is nothing but A plus H. What is OA? That is A. Plus A and minus A get cancelled. So PR is equal to H. Now just replace these values in tan theta. What about tan theta? That is QR by PR. So substitute the values of QR and PR in tan theta. That is equal to QR by PR. That is equal to f of A plus H minus f of A by H. So that is the value of tan theta gives f of A plus H minus f of A by H. So both of them are equal. From the previous, we know that y2 minus y1 by x2 minus x1 is also f of A plus H minus f of A by H. So tan theta, value of tan theta is also f of A plus H minus f of A by H. So both of them are equal. Since both of them are the formula for finding the chord. And we concluded that in the triangle PRQ, tan theta equals f of A plus H minus f of A by H. That is the slope of the chord PQ. Here the slope of the chord is tan theta, and here tan theta we calculated as f of A plus H minus f of A by H. Here these two values are equal. So slope of the chord equals f of A plus H minus f of A by H equals tan theta. Now apply the limit. Here 2 points A and A plus H. A and A plus H on the x-axis. Now distance between A and A plus H is H. Now try to reduce H distance. This H distance is reduced. That means that A plus H is moving to left direction or left side. Then only reduce H distance. So in the first figure, a distance between A and A plus H is H. Now A plus H point is brought here. So the distance is reduced. So connect P and Q, we got a chord. In the next figure, A plus H point here brought here. So the distance is reduced. Then we got the chord PQ. In etc. At some point, the H tending to 0. That means the distance between A and A plus H are very small. And that chord is same as, or that chord is converted into tangent. As h tending to 0, that means a and a plus h are very close and also q comes near to p. H tending to 0, the distance between these 2 points are very small. At that time, q comes near to p. Then what happens to the straight line? The straight line PQ, that is a chord that here these two figures, the PQ is a chord, that chord, that straight line is converted into tangent. That chord is converted into tangent. We can observe that in the figure. I'll explain it again. In the figure 1, we have a straight line to the PQ chord. Then we try to reduce the H distance. At some point, H distance tends to 0 or very small. Then at that time, Q point comes near to P. Then the straight line is converted into the tangent. We can observe that in the figure. As H tending to 0, Q tending to P. Both of them are almost same. So that limit h tending to 0, f of a plus h minus f of a by h equal to limit q tending to p, qr by pr. The chord pq tends to the tangent at p of the curve y is equal to f of x. Limit h tending to 0, f of a plus h minus f of a by h, that means that is equal to the slope of the tangent. Instead of this, we write f dash a, that is equal to tan theta. That's about the geometric interpretation of derivatives. Concluding as at the beginning we had just a chord PQ. Chord PQ. And that chord PQ becomes the straight line. As the H value is tending to 0, at that time, this is A and this is A plus H. This distance between these 2 points is H. Here H tending to 0 or A and A plus H are very close. At that time, the point P and Q are very close, or Q is near to P. At that time, the straight line is converted into the tangent. So, here limit h tending to 0, f of a plus h minus f of a by h is equal to slope of the tangent. That is nothing but f dash a. F dash a equal to tan theta. Is it clear? Thank you.